For a social studies project, Amit had to make these 10 different road signs. So what he observed is that in each case he is to make a triangle with red outline. The only thing that is changing is the symbol inside. So he decides to make 10 different triangles with white chart paper and red tape. And then he says that after making these 10 triangles, he would make whatever sign he needs in the center with a black marker or sketch pen. So he decides to make 10 triangles, equilateral triangles with side 20. So he decides that he'll make equilateral triangles. So all the sides would be equal since it's an equilateral triangle. So the first thing he wanted to know was how much tape would he need. So the red tape that he needs is actually the distance along this shape. Now the distance along this shape or along the boundary of this shape is what we call as perimeter. So perimeter is actually the distance along a shape. So for an equilateral triangle with side 20, he knows that all the sides would be equal. So perimeter would be 20 plus the second side, which is 20, plus the third side, which is again 20. So he finds that perimeter, let's say perimeter is denoted by the letter P. So perimeter would be 20 plus 20 plus 20, or I can say 3 times 20. So perimeter is equals to 60 centimeter. So now he finds that this much tape, 60 centimeters of tape would be required for one triangle. How many triangles does he have to make? 10 of these. So for 10 triangles, he would need 10 into 60, that is 600 centimeters of tape. So this is how we find the perimeter. Now in general, perimeter can be given as sum of the three sides. So if I have a triangle with sides A, B, C, I would say the perimeter is A plus B plus C. For any triangle, the sum of three sides is the perimeter. So here I have one side is at 18.4, the second is 28, the third is 30. So perimeter would be 28 plus 30 plus 18.4, which is 76.4. So that becomes the perimeter of this triangle. Now he has found the perimeter, that is, he has found how much tape he needs. The second task at hand is to find how much chart paper does he need. To find the chart paper he needs, that is, say the yellow region, this is the chart paper that he needs. So for the chart paper, he actually needs to find the region that is inside the triangle, that is area of the triangle. So how would you find the area of a triangle? So we have this as a triangle and we want to find its area. So we want to find the white region that is inside it, that is the area. So I select this shape, I take a copy of it. So I get two triangles now. If I rotate this triangle in such a way, I rotate it such that it inverts itself and then I bring it towards the first triangle. Now I join it in such a way that it becomes a parallelogram. So now I can say that area of a triangle, because this parallelogram has two triangles now, two same triangles. So area of one triangle would be half of the area of this parallelogram. We know that area of parallelogram is given by base into height. So since area of parallelogram is base into height, so I can say that area of triangle is half into base into height. What is this base? This is the base, the side at the bottom. And how do we define a height? From the base, the perpendicular distance to the opposite vertex. So if this is the base, opposite vertex, perpendicular distance. This is the height. So area of the triangle is half into base into height. So it does not only hold true for an equilateral triangle. Let us see for any triangle, we can say it's half into base into height. How? Again, I can take a copy of this, again reflect it, and then bring it close to the first triangle such that I get a parallelogram. So I complete a parallelogram again, and hence I can say that area of this triangle again was half of area of parallelogram, which is base into height. So for any triangle, I can say that area of that triangle is half into base into height. So now he had to find area of this triangle, which was an equilateral triangle with side 20. How does he find the area? He needs to find the base and height, and so he can find the area. We know that the base is 20. All we need to do is find the height of this triangle. So let's draw a perpendicular. So let's say we draw a perpendicular. So now this becomes a right angle triangle. Drawing a perpendicular, I get a right angle triangle. So I can apply Pythagoras theorem here. So I get this side is 20, which is the hypotenuse. One side is 10, and this is the height of the triangle. So we know by Pythagoras, height square plus the other side is 10 square would be equal to the square of the hypotenuse, which is 20. So I get 20 square. So from here I can say that h square plus 100 would be equal to 400. 20 square. Now h square will be equal to 400 minus 100. So h square comes out to be 300. H would be taking square root. Since h is the distance, it cannot be negative. I ignore the negative root. I get under root 300, which is under root 100 is 10. So I can take 10 outside, and what I'm left with is 3. So I get 10 root 3 as the height. Now to find the area would be half into base into height. So I get half. Base is 20. Height I just found. It was 10 under root 3. So 10 under root 3. So from here I get 100 root 3. Now this is the area of this triangle. He needs to make 10 such triangles. So the area of 10 such triangles would be, so total area would be 10 into area of 1, which is 100 root 3. So I get 1000 under root 3. Since it's in centimeters, centimeter square. So this is finally the area that he needs. So this is the total area that he needs. This is the amount of chart paper that he needs. So we've seen that for a triangle, perimeter is given by sum of the three sides, and area is given by half into base into height.